Being one of the best preserved buildings from the classical era, the Pantheon stands as a colossus in Western architecture, inspiring copies and creative reinterpretations such as Hagia Sophia in Istanbul and St. Peter's in Rome. But who was originally behind its construction? The answer is in the inscription below the main pediment: Marcus Agrippa Lucius Filii Consul Tertium Fecit, which would translate into built by Marcus Agrippa, son of Lucius, when he was consul for the third time. So, Marcus Vipsanius Agrippa, the great consul, general and statesman who served under the first de facto emperor of Rome, Octavianus Augustus, is considered to be the original mind behind the Pantheon's construction, dating the original foundation of the building back to the year 25 BC. But does this mean that the building we see today is really Agrippa's original Pantheon? Well, of course, that's not the case. The building was in fact destroyed twice by fire, to be eventually restored, as brick stamps found on site would suggest, by Emperor Hadrian around the year 125 AD. The Greek word Pantheon literally means of all gods. As such, we could think of it simply as a temple dedicated to all pagan gods. But truth is, the Pantheon was quite a bit more than that, and to understand its true purpose, we need to combine its location, orientation and architecture. Campus Martius, a piece of land between the city and the Tiber, property of Lucius Tarquinius Superbus, the last king of Rome, to be then used as a military camp dedicated to the god of war Mars after the Etruscan king's exile. More than that, it is the place where the legendary founder of Rome, Romulus, is said to have ascended to the heavens. Surprisingly related to this legendary tradition, each year on the day of the foundation of Rome, the 21st of April at noon, if we had to stare at the massive dome from within the Pantheon, we would witness what could be considered to have been, back in the days, one of the first visual effects in history, with sun rays penetrating through the opaion at the top and bathing in sunlight the entrance to the main building and the person that was supposed to make his glorious entrance right through it, the emperor himself. Was then the Pantheon maybe a place where to worship the apical figures of Roman societies? Another clue may come from the fact that the Pantheon was not only oriented as to allow for such a light show on the anniversary of the foundation of Rome, but it was also perfectly aligned to another building that was being constructed at that very same time, the Mausoleum of Augustus, in what can be hardly seen as a coincidence. The pediment would have been decorated with a gilded bronze eagle holding a crown of oak, a fact that would recall both the moments recounted by Suetonius when a real eagle landed on that very same tympanum, but also the symbolic rituals that would take place right in front of the building. Massive funerary pyres of deceased emperors, which flames would consume the knots holding an eagle imprisoned in a cage. The eagle, eventually free, would then fly off, carrying with its mighty wings the divine aspect of the emperor, liberated from his mortal remains. The Pantheon does indeed stand as a connection between Rome and its own legend, a mystic place where to worship the divine nature of the rulers of the Eternal City. Today, the Pantheon is a Catholic church named Basilica Santa Maria ad Martires as a consequence of the donation in the year 609 AD by Emperor Phocas, and this is probably the reason why the Pantheon managed to escape abandonment, destruction and major spoliations. So, when we see paintings of the building containing features that are lost today, like the Twin Towers bells at the top of the intermediate block, that's because of the many attempts that have been done over the centuries to make it look like a proper church. The aim of this video is to rebuild the Pantheon as it would have appeared during Hadrian's reign. In doing so, I'll go through the different structural elements of the building, the front portico, the cylindrical drum with the massive dome on top of it, and the intermediate block that functions as a transition between the two. My research was based mainly on the book The Pantheon from Antiquity to the Present by Todd Marder and Mark Wilson Jones, which is quite detailed in depicting the evolution of the building through time. In addition to that, I used as well all of the material I could find online, organized in a quite handy Milanote board. During the centuries, we have witnessed an evolution in the methods that can be used to survey architecture, from drawings all the way to photogrammetry and laser scans. In this case, I decided to follow the old, more affordable but romantic route, which is to leverage on plans and sections as depicted by past prominent figures in the architectural field. And we have many of them that focus on the Pantheon, especially in the 18th and 19th centuries. For this project, I used the floor plan and side view coming from the work of Antoine de Godet. The geometry of the Pantheon is very helpful in this whole process. In fact, we know that the main building, known as Rotunda, would contain an inscribed sphere with a diameter of 150 feet, approximately 43 meters, with the upper and lower extremities of the sphere touching respectively the ground floor and the opening in the dome. To further assess the correctness of this approach, I placed as well a cylinder in correspondence with one of the columns of the Portico, and I moved a bit the references trying to make them match at some of their obvious junctures. I then used the cylinder to measure the height of the shaft, verifying that this would amount to its real value of 11.8 meters. Additionally, I measured the height of the dome as well, which should be around 21.7 meters, and the diameter of the opening, which should be instead around 8.8 meters. Another interesting geometric feature of the Pantheon is that if we inscribe a cube within the circular plane of the Rotunda and we then replicate it and flip it to the north, this will delimit precisely where the Portico is. And this theme of spheres and cubes or circles and squares is actually repeated all over the building, as you may notice for instance from the pattern of the internal floor. With these references correctly sized and placed, it was time to move on to the actual modeling process. One of the first things that we notice when we look at the Pantheon is its massive set of Corinthian columns. The building is octastyle, which means it has 8 columns at the front, while other 8 are placed in pairs right beyond the first row. And what is even more impressive is that all of them are originals, except for the 3 columns on the east side, which are those better preserved that were lost and replaced in the 17th century by Popes Urban VIII Barberini and Alexander VII Chigi. If you look close enough, you can indeed spot a B, which was Barberini's sigil, still standing on the abacus of one of these replacement columns. During the past few years, I have tested different methods for building Corinthian columns in Blender, one of which you may find in this video here. This time I tried something a little different. I placed all of the single items that constitutes the capital into a dedicated collection to be then used as instances produced by a geometry node system. In this case, the instancing points can be created with a curved circle, since all of the items are arranged in a circular fashion. Moreover, using a curve we can easily align each instance to the tangent at that point of the curve to get the correct orientation. In this way, it becomes pretty easy to manipulate the instances' placement, number, overall orientation and specific rotation on their respective local axes. With a base system in place, I would group all of the nodes together to then create input parameters to be used from outside of the group itself. One of the advantages of this is that I can duplicate the group and reuse it for another element of the column's capital. I would then create the column's base and its plinth as well, again placing the meshes into their own separate collections. And the same I would do also for the shaft, which again I knew to be 11.8 meters tall. For the tapering at its top, an interesting study from Josie Noon shows that, in compliance with the rules set out by Vitruvius, the upper radius of the real shafts on site is on average 0.87 times the radius at the bottom, and this is the ratio I used in my reconstruction. For the entasis, or in other terms the increase in the diameter of the shaft happening at 1/3 of its height, I run a couple of edge loops, removing that on the upper side and then gently scaling up the remaining one. Assembling the entire column would be at this point very simple. It is enough to bring the different collections within a new geometry node system and join them together. To then instantiate the column, I just converted the plane on which the geonode system is applied into a point where the column would eventually spawn. In this way, by either using an array modifier before the node tree or just by simply duplicating the plane in edit mode, I could get all of the 16 columns in place. This way of nesting instances is pretty awesome performance-wise, as it is actually the only way to keep compositions like this manageable by both the software and the hardware. Speaking instead about materials, there is another interesting story to tell. The 8 shafts in the front row are made of granite of grey hue coming from the quarry of Mons Claudianus in Egypt between the Red Sea and the Nile, while the other 8 shafts are of pink granite from Aswan. These shafts, each carved from a single block of stone, would weigh 50 tons. Just imagine the logistic effort that was made at that time to transport such a massive compressive weight for over 2000 kilometers from Egypt all the way to the port of Ostia and then to Rome. A theory proposes that the initial plan for the shafts was to be of even greater size, weighing no less than 100 tons, but for some reason the columns originally intended were lost, probably due to a shipwreck, and the construction proceeded with the smaller ones that we see today. This would explain the oddity of the presence of a second pediment in the building, which indeed is rather unusual for classical architecture, and that was probably at that point necessary to compensate for the lower than intended height of the portico. To reproduce these two types of granite, I leverage on my marbles shader pack, which if you want you can find at the link in the description, and that will be soon updated to contain all of the different materials that I used in this project. The idea for the shader is quite simple and revolves around noises used to produce the different desired patterns, displaced in turn by other noise nodes to allow for additional control over the scattering factor. All of the patterns are then placed on the mesh by simply projecting them, and in fact basically no UV unwrapping was used for the entire scene. For a full explanation of the shader you can watch this other video here. So, while the shafts were made of Egyptian granite, capitals and bases were of white Pentelic marble coming directly from Mount Pentelikon in Attica, Greece. This is the same marble that was used to build the Parthenon in Athens, as well as much of the Acropolis. Again, I used my shader pack to build a preset for it, and with that in place I was ready to move on to the actual texturing process. The most efficient way to set up materials for my instances would be to use a set material node for each of the different pieces directly within the main geometry node system. In this way, I'm not really limited to the specific set of materials for each respective mesh, and I can instead create multiple material variations for the same instanced mesh depending on the context, as I will do for the interior of the Rotunda. I then proceeded to make a few adjustments to the applied materials and worked a bit on the randomization of the materials placement on each instance by combining the output of the texture coordinates node with the random output of the object info node. One last touch was to combine a grunge map with a gradient texture node as to simulate dirt piling up on the lower end of the shafts. The next step in the modeling process was to recreate the entablature at the top of the columns, and this would be the classical Corinthian entablature with the three fasciae of the architrave, a plain frieze and the upper cornice hosting a variety of decorations, such as the typical egg and dart ornament along with corbels and rosettes. As usual, the best way to distribute a mesh like the one representing the entablature would be to make use of the always useful shear tool, which is the simpler way to get sharp angles with constant thickness. When it came to reproduce the various ornaments, I either revolved on using my classical molding pack, which again you may find at the link in the description, or I proceeded to model them from scratch. Also in this case, I'm going to post pretty soon an updated version of the pack on the store containing all of the new decorations I created since the last update, so you may want to keep an eye on that too. The most efficient way to get the job done is again to rely on instances and geometry node trees. For this, a couple of simple solutions are to use either a grid node or a mesh line node in order to get the points upon which the different meshes should be instantiated. You may ask yourself how you can mirror such compositions in context where you need indeed them to be mirrored along a specific axis. You may think that you could get away with a simple plane working as the instancer in addition with a mirror modifier right before the geonode modifier. But if you go down that path, you would realize pretty soon that this method is not really viable, as you have limited control over how to get the mirror mesh with the right orientation. Plus, this is not really usable when working with mesh lines or grids. In these latter cases, a solution to the problem may be to add a mirror modifier right after the geonode modifier. But to make this work, you will need to transform those instances into real geometry, which kind of defeats the point of building an instantiation system to begin with. Given that, an easy solution is to create a parallel branch right after the instantiation of the node tree, where the additional instances would be translated on the desired axis by a value that amounts to minus the translation factor of the main branch. At this point, all we would need to do would be to join the two branches back together and give a proper rotation to the instances of the second branch. With this in place, what we basically have is a sort of synthetic mirror modifier built right within the node tree, with no duplication of the original existing geometry. But what if we want to enable and disable the mirrored instances with just one click, as we would do with the actual mirror modifier? That's quite easy as well. We just need to add a switch node and to create a new boolean input parameter and connect the output of the switch node to the tree's output. When the state is false, we would use just the original branch, while when the state is true, we would instead employ the output of the two branches joined together. This is essentially the system that I used for all of the GeoNode systems in this project, and this method would allow me to easily create these section views of the entire building with just a few clicks. Another interesting part of the process was when placing the rosettes along the entablature, which are supposed to sink deeper within the entablature itself. To create the necessary recesses for that, I paired the rosette mesh with a cube exceeding the rosette's height both upward and downward. I then positioned the rosettes where I wanted them to be, and I then added to the tree the paired cube in those very same spots. With that done, I would bring the interested piece of entablature within the GeoNode system and pass it through a boolean node set on difference along with the rosettes cubes. In this way, I could keep the positioning of both the rosettes and their respective recesses as procedural and tweakable as possible. The last step was to then bring the actual rosettes back into the node tree and join them with the rest of the tree. Once the entablature and its decorations were completed, I started texturing them using the white preset of my marble shader pack, tweaking the different parameters and creating entirely new material variations when I felt it was needed to make some of the meshes pop out more. For the pediment instead, I created a tiled marble material to simulate the effect of its real counterpart. I then started working on the squared Corinthian columns of the portico. Also in this case, I created the shaft, base and capital, and I put each of them into separate collections, recombining the different pieces together with a GeoNode system in a similar way I did for the rounded columns. With that in place, I started positioning the columns according to the floor plan reference. It was now time to work on the two big niches that you can still see today behind the 16 rounded columns of the portico. Agrippa's original intention was likely to dedicate the whole building to Augustus, to the point that, if he had to follow Greek traditions, the Pantheon should have been called Augusteion instead. In particular, he wanted to erect a statue of the first Roman emperor within the building. But Augustus himself must have rejected the idea of presuming this honor while still alive, preferring to have his statue placed with that of Agrippa in these two niches on the outside. Another suggestive element that can be found in this external part of the Pantheon is the massive bronze door that connects the portico to the interior of the Rotunda. There have been many speculations about whether the 7.5 meters tall ante are original or not, and we do not have a final answer on that, but some believe these are the doors designed by the original Roman architects in the 2nd century AD, which would make them the oldest in Rome to be still standing to this day and a rare example of Roman monumental bronze surviving. Once I finished the modeling of the main part, I moved on to this grid-like mesh right at the top. For texturing, I created a procedural bronze shader from scratch. Now, this was before the release of Blender 4.3 with its new metallic BSDF shader, hence you can see that here I'm still using the standard principle BSDF. Apart from this base version of the shader, I created an additional variation as well to be used for gilded bronze objects. I then focused on the arches at the top of the entablature and on the series of bronze trusses supporting the overall structure of the roof. These in particular were actually removed and melted down by Pope Urban VIII in the 17th century and used for the cannons in Castel Sant'Angelo and probably for Bernini's baldacchino in St. Peter's Cathedral. Hence, today what we are left with is just their wooden replacements. The outrage subsequent the stripping of bronze from the Pantheon led to satire begin circulating among people. The floor of the portico has a quite specific pattern, with circular incisions of dark stone mixed together with the overall whiteness of the marble. These kind of patterns are usually pretty easy to reproduce either in Blender or in some other dedicated softwares such as Substance Designer. But given the fact that I wanted to use my own asset pack when texturing without having to create additional resources, not even masks, and given the simplicity of the geometry, I decided to actually model the different shapes and to place them into their intended positions using eventually a boolean modifier on the floor mesh to get the desired result. And I did this for both the central aisle leading to the main door and for the lateral aisles ending with the niches. For the texturing, it was then just a matter of assigning the correct material to each piece. To avoid getting a lazy texture look, even though this is not a texture at all, I added a bit of an irregular effect to the floor, feeding a noise texture with big, smooth grayscale transitions into the height value of a bump node, and I connected this to the normal input of the shader. I also gave the floor a big tiles pattern to enhance the sense of separation of the shapes. In this regard, increasing a bit the bevel value of the different meshes that compose the overall pattern was a big improvement. Another trick to separate the floor from the objects standing on it is, within this material setup, to multiply the output of the ambient occlusion node into the base color as to increase the visual perception of shapes being distinguished from one another. To complete the base of the portico, I imported my procedural staircase generator and I started assembling the frontal and lateral steps. Today, this part of this building is submerged under the surrounding terrain and hence not entirely visible, but in the past it has been even worse than that, to a point, at least for sure in the 16th century, where in order to get to the floor level of the portico, you would have had to actually descend downward using a staircase, as the level of the overall ground of the terrain surrounding the Pantheon was a lot higher than today due to the accumulation of mud and debris. To reproduce the bronze writing positioned right below the pediment, there would be at least a couple of possible options. The first using normal maps and the second, which is the one I chose, creating the actual corresponding geometry. To do that, I added a text mesh to the scene. Now, the most lookalike type of font with respect to the original writing I could find comes from a family of fonts called Thracian, which indeed takes inspiration from the incisions used in buildings during the Classical era. With the writing roughly in place, I used a solidify modifier to give it the necessary thickness, and I then converted everything into a proper mesh. By doing so, the topology would be completely messed up, but that wouldn't be actually a concern since I knew I was not going to unwrap it, using instead my procedural bronze material to texture it. In order to get rid of this custom type writing feeling and make the composition a bit more similar to its real counterpart, I started messing around with each letter, adjusting the horizontal thickness where needed, reshaping, rotating, scaling and repositioning the different meshes to give to the whole writing a bit of a less regular look. The final step in recreating the portico was then to add the main decoration to the pediment. I knew that this was supposed to be an eagle holding a crown of oak. For the eagle, I just purchased this nice 3D model from Render Hub, while for the crown of oak I borrowed one of the leaves in my garland decoration, giving it a bit of a bend and positioning it as an array along a section of a circle. With this very same technique, I modeled as well the sides of the pediment's decoration. With the portico in place, it was now time to move on to the rotunda. If we look at it from the outside, we could ideally subdivide it into three main sections, each delimited by a profile molding running around the circular pattern. I started by displacing a piece of the portico's podium along a circle, adding then a simple cylinder for the main outside walls. One ingenious characteristic of the rotunda, which is common to many other classical buildings, is that the alternation of filled and empty portions would serve a structural purpose. In fact, this would work as extra piers that, along with the many arches distributed along the circumference of the building, would ensure that the overall weight of the structure is properly managed. When it comes to cut holes through a subdivided mesh without affecting its shading, as it is the case here to create the openings at the base of the rotunda, one possible way is to use a much denser unmodified version of the same mesh as the target of a shrink wrap modifier applied on the original mesh. We can even use vertex groups to ensure that only a specific part of the original mesh is affected by the modifier, so that we can continue modeling the rest of the mesh without any kind of limitation. Within the rotunda at the ground level, walls are spaced out by the presence of exedras or recesses in the internal walls placed along both the main axis, where they show a circular shape with the one on the opposite side of the entrance door being the main altar, and the diagonal axis, where instead their shape would follow the curvature of the rotunda. A series of columns would then be placed around the circular perimeter of the room. In the entire Pantheon, there is only one variety of marble coming from Italy, Carrara, and it is used for the capitals of these columns. Corinthian columns with a squarish shaft are placed in correspondence with the transitions between the main walls and the internal walls of the exedras. For that, I created a mesh circle with a geonode system assigned to it. Within this, I joined together the three collections for the column, similarly to what I had done for the portico, and I then instantiated them along the circumference of the circle. You can see that I converted the circle mesh into a curve, and that is done to exploit its tangent as to properly align each column in the right way. Now, the problem is that I only need to have my columns in some very specific spots. A nice trick to do that is to create a vertex group on the same mesh where the genode system is applied, where I would put all of the vertices upon which I do not want to have an instance placed. Then, by connecting an empty input to the selection socket of a delete geometry node, and by toggling the input icon in the modifier stack, we can select the newly created vertex group. In this way, it is enough to add the vertex we want to remove to the vertex group, and if we have the delete geometry node set to instance, the corresponding mesh will just disappear. Moreover, with one vertex selected, by tapping G twice, it is possible to move each instance right at the desired spot while keeping the correct orientation. This is the method I employed for both the square and rounded shaped columns of the Rotunda. I proceeded by adding the entablature on top of the columns, using the same pieces already modeled for the portico, as well as the straight section going close to the main door. The floor of the Pantheon is a combination of different stones arranged in a specific pattern where circles and squares are dominant. Pavonazzetto, which is a white marble with dark red veinings quarried in the region of Phrygia, modern Turkey, is combined with giallo antico or marmor numidicum, a precious variety coming from the African provinces, along with grey granite and porphyry. Porphyry, in particular, has been used extensively in decorating the interior of the Pantheon. This rock of purple hue, which comes from the Egyptian desert, became to some extent the imperial stone par excellence, and it will be used throughout the history of the empire, not only in architecture but also for monuments. Quite famous indeed is the trend developed during the 4th and 5th centuries that would see imperial sarcophagi being built entirely from porphyry. Floor patterns are arranged in diagonal lines, even though, for unknown reasons, at least to me, not entirely consistent with the presumed color scheme. This is one of the reasons that brought me to the decision of employing a method similar to the one adopted for the floor of the portico, thus avoiding creating a specific texture set and modeling instead the base models by hand, assigning in a second moment the different materials to each piece. And again, of course, I leverage on my marble procedural shader pack, to which I would add the required materials as new presets. The Pantheon, as we know, has an opening at the top, but for some reason it seems that rain would still be deflected somehow, a thing that would prevent it from entering the building. Some theorists try to explain the curious fact by talking about ascending and descending streams of air. And while this may be true to some extent, if we take a closer look at the floor, we would see some little holes connected to the draining system that, along with the fact that the floor itself is convex in shape, would allow for water to be quickly dispersed from the building. To create the internal walls, which are as well highly decorated with many different types of marble and stones, I used a technique similar to that employed for the floor, where I would create this sort of panels containing all of the different shapes that I need already arranged as to match the pattern of the actual wall. These panels would be then bent with the use of a simple deform modifier based on the needed curvature, and they would be positioned in the right place. For the bending in particular, I ensured indeed that each modeled piece would have the necessary amount of vertical geometry. Again, I would assign to each individual piece the corresponding material, sourcing through the different presets available or creating new ones where needed. I continued building the different panel variations to cover for all of the exedras and internal walls, and I modeled as well the 8 ediculae, which are these structures with a podium and columns supporting a little pediment, which are perfect homes to statues and that are placed in between the exedras themselves. Statues of the different gods of Roman tradition were placed back in those days within both exedras and ediculae, and this may indeed be the reason why the building was referred to as a pantheon. But these statues would then be progressively replaced with statues of emperors, again supporting the thesis of a place for imperial worshipping. In more modern times, the Pantheon served instead, among other things, as a burial place for illustrious figures. The Prince of Painters, Raphael, is in fact buried in the Pantheon today, along with Annibale Carracci, Baldassarre Peruzzi, and the kings Vittorio Emanuele II and Umberto I. On top of the internal entablature and right at the base of the dome lies the second level of the Rotunda, called Attic. This higher register has represented in the past a kind of an architectural oddity or mystery. In fact, the attic did violate one of the tenets coming from the Renaissance, but inherited from the concepts of classical design, which would dictate the placement of solid above solid and void above void, to the point that the hypothesis of different architects being involved for the different registers of the Rotunda has been from time to time brought forward by artists and historians. Truth is that to amend this visual oddity, the attic registry underwent a massive remodeling in the 18th century by the young architect Paolo Posi. The new scheme remains in the building for all visitors to see. A dull combination of rectangular fields and pedimented window frames. This revision would later be considered as an unpardonable barbarism or simply deplorable. It was under Benito Mussolini that it was commissioned for the attic to be returned as much as possible to its ancient state, with only a small section being eventually truly restored. If you want to have an idea of how the Pantheon would have actually looked like before Posi's remodeling, just take a look at this beautiful painting from 1734 by the Italian view painter Giovanni Paolo Panini. And this is the version of the attic register that I try to reproduce, given the overall aim of bringing the Pantheon back to its time of splendor. As such, I modeled also in this case the different marble panels, again with a particular care on their vertical geometry, while for the little columns or pilastrini, I employed the same vertex group technique used for the placement of the columns at the ground level. It was then time to finally move to what is probably the most astonishing feature of the Pantheon, which is its massive dome with its famous hole in the top. This giant dome has been the largest ever built in the world for 1300 years, surpassed only in 1436 by another Italian masterpiece, the Dome of Florence Cathedral, engineered by Filippo Brunelleschi. And it is still to this day the largest unsupported concrete dome ever built in human history. The dome is arranged in a specific pattern where the coffers are divided into 5 concentric rows of 28. These numbers express an idea of perfection and are associated with virtue, moderation, and beauty. To get the structure of the dome in place, I used a vertical array with 5 repetitions, and I then applied it to model the part at the top that will form the oculus. I then used another array modifier, this time with 28 horizontal repetitions. At this point, I bent the coffers in a ring shape using a simple deform modifier, welding the touching fringes, and I eventually gave the ring its final shape with another simple deform set on bend and placed right above the first deform modifier. In the process, I ensured I had enough geometry to work with to make the bent mesh look smooth enough, and with the help of proportional editing I fixed a bit of the overstretching happening in the top rows. The coffers of the dome were filled with gilded bronze ornaments, and since the dome should have been a representation of the heavens, it's likely it would have been decorated with stars. For the same reason, the interior would have been probably tinted with a sort of a bluish hue layered on top of the concrete. The exterior part of the dome consists in this series of little steps converging into the opaion at the top. This outside structure is today protected by a dressing of lead, while originally it would have been covered by bronze tiles. The exterior of the Rotunda instead reveals today the brick composition at its core, but back at the times of Hadrian's reign, this would have been embellished entirely with marble tiles. More realistically, given the fact that marble is and was a quite expensive and scarce material, this would have been integrated with travertine and white stucco as well. At the end of the whole process, this was my final result.